This is Planetary Dispersion, a widget that I made in the Unreal Engine. You can download it on the Fab Store right now, and as you can see, it's sort of sci-fi looking with its neon lit border and with many different controls to manipulate. So you can control the absorption in the atmosphere from high and low frequencies. You can alter these absorptions and filters based on the temperature of the atmosphere, altitude, the humidity, its pressure in the atmosphere, change various intensities of these filters. Dispersion is about how quickly frequencies move in space. So generally higher frequencies moving faster than lower frequencies. So as you can see in my Planetary Dispersion widget, there are 9 different bands from 1 till 9 from top to bottom. And there you can control offset, which is the delay in which that frequency arrives, which one arrives first and which one arrives last. And the middle one is base LPF, base low pass filter, which frequency that band is to affect. So 250 hertz, 400 hertz, 700 hertz, and so on. Absorption is the amount of frequency cutoff. So you can cut off, a certain amount for each frequency. And different planets have different settings. So I've got 9 planetary settings, including various planets such as Saturn, Jupiter, Venus, Mars, Earth, and also some moons, so our moon and Titan. And there's some other settings for like a sci-fi where they're not the usual settings that you would expect for planets. And then a reference planet as well. So you can compare between where settings are more neutral and then compare it to other planetary settings. So generally across the planets, there are a variety of speed of sound. So you can see that setting on my widget. You can see speed of sound. So Earth, roughly 343 meters per second. So that's how fast the sound will move. In the top right-hand corner, you can see distance. So if I move if I press S to go backwards and forwards, I'll take away the widgets for a moment. I can move back and forward from this little marker. So as I move back and forth, the meters change. So currently I am 536 meters from my target sound source. So that marker indicates the sound reference point. And you can move away from that point or move towards that, and the sound will reach you at different speeds. So I'll start with Earth. So I just wait for the sound to finish. It takes about, it's a 4-second sound of pink noise. And so I am 536 meters away from that, and it gives me an estimated time for that sound to reach me. So 1.563 seconds to reach me. So as I press the button number 3 to indicate Earth, it will be a delay of 1.5 seconds, and then that sound will come to me, and there will be low atmospheric loss on Earth and low high frequency loss. There will be some temporal dispersion, but very subtle or none. So in this view, it gives you the information that you need, and you can really push it back and then not hear the sound for a few seconds. If I go back to my widget, I can still see the reference. We are currently in Earth settings, and I can change between different planets now. So I'll change to Jupiter. I am currently 1,699 meters from my sound source. So even in Jupiter, there's a bit of a delay. So I'll just walk forward a little bit and to make that sound more instantaneous. Now, if I change to something like Mars, you will see the settings alter. Mars is a little bit quieter than the rest of the planets. And I can actually turn gain off. So I could set it up so all the planets are of the same volume. Even though there are these kind of timbral differences, I can level it out and make them all the same volume and compare them on a timbral level rather than a volume level. So if I go to my amplitude contrast, I can turn that down or turn it off. And now we will hear no gain differences between the planets, which helps in comparing them. Of course, you'll still hear gain differences because they are being filtered still. Sometimes when you change the timbre or the filtering, it still changes the volume, but there's less of a volume difference than there would be. Amplitude contrast setting also takes away that distance thing I mentioned before. So you can really go back really far away, almost 2 kilometers away from your target source. So right now I've just talked about the different filtering. So base, LPF and absorption are the filter mechanisms across the 9 bands. The offset is the planetary dispersion, which is delay time, the delay time it takes for each individual band. So we've got like a few microseconds differences between highs and lows, highs arriving first and low frequencies arriving later. And you can make that difference more extreme by using the atmosphere intensity button. So if I was to really increase that offset and dispersion will be more pronounced. It's more sci-fi-ish, so maybe not something that would be so common in other planets, but it gives you a sense of what is actually being changed if it's not apparent when you're listening to the other planets. I'm going to change my sound source, so I can change from pink noise 4 seconds to a gong sound. I can do pink noise 10 seconds. I can do a short metal hit, which is good for really hearing the impulse differences. I can just use white noise if pink noise is not enough. You can do a cymbal sound. You can do a sine tone, a very low sine tone sound or a very high sine tone sound, and various piano. Just kind of give a full-bodied sound of things that we are familiar with. I can also pitch shift these test sounds using C and V, so I can, if they're not in the right frequency range that I need them to be, I can just put them up and down. So I'm going to start with gong. So I'll just listen to that first. I will put the atmosphere intensity back to 1 because that's the default. Sound arrives when you really increase that atmospheric intensity. So we're stretching out that offset, so the delay is very obvious. And if I bring it back, it should go back to its original sound. So transition time's an interesting setting. You can see the parameters move slower as you transition. So let's try. So they move much more slowly. If I move it to something like the white noise, let's have a listen through the differences. Increased transition time. There are other settings like that where you can just alter the frequency bands like that. So firstly, we'll start with pressure. We will just adjust the pressure of the planets. Now these are customized settings. They're not like, I'm not suggesting that this is the amount of pressure on that planet, or this is the temperature changes on a specific planet. You're in control where you can set the effect of temperature and pressure, which is usually the amount of absorption, which part of the frequency band you want to affect. But you're in control of saying what those differences would be for those particular planet settings. It just allows you to alter that. So obviously with pressure, you can see it moving the pressure a little bit. Temperature changes, the base frequencies, altitude changing, and then we also got humidity over here, changing the absorption much more drastically. So humidity is on Earth, humidity is the moisture in the air, but on other planets, you may not be specifically water, but could be other chemicals or other substances. But it's this idea of a dampening. It somewhat dampens the atmosphere or the base composition. Further to that, we also have a settings called Flux. So Flux takes into account that these settings on planetary environments are not stable, not always stable, with lots of weather changes or variety of things that occur on planets. So it allows the parameters to flux, to change in real time. So I'll just press that button. So the flux, as you can see, things are just gliding and moving ever so slightly, and you can increase the amount. You can turn up the flux, and it will turn up the intensity of movement. So pressure also changes during flux, as you could imagine in some sort of gas or pressure weather system. And also you can see the wind. I've got a wind sound parameter, and that also moves. So you can imagine if you had weather like on Mars, wind, it would be more intense or less intense at various times. So if I can actually turn the wind on, so I'll try that. So that lever indicates the volume of wind. So the volume turns up and down as if you were, walking through a dust storm. Yeah, so Flux will move that wind volume up and down and alter it slightly. So I'll just turn that off. Another important aspect about this system is you can control the medium at which you're working in. So on Earth, we have an atmosphere, we have air, and on the other planets, there are other types of atmosphere. Some have no atmosphere, but some have varying types of gas compositions. So you start off in atmosphere, but you can also change it to water. So I'll change from atmosphere to water. Oh, I can also loop the sound, so I'll just hit loop. There is also other types of mediums that you can work in. So you've got the regolith, the surface of the planet. So you think of something like the moon has a layer of dust, and that sound can travel on that surface, that material on the surface. Sound does travel through those as well, and they could travel up your suit or something, or through your boots, through conduction or something like that. Or you could intentionally try to get the vibrations and turn them into sound. Sound moves very quickly, much more faster through Regolith. That's interesting. And there's also ice, as if you discover some sort of ice planet and you can hear what sound would be like on those. Other aspects of this is that you can also choose environment type, because I also understand that if you were recording music on another planet, you wouldn't just get the same old thing. You wouldn't just get open plain, area, and that's it. And there's no more differences in the types of sounds that could happen. So there would be like caves and craters from meteorites. So you can have, firstly start with no environment type, or you could try an open plane. These are differences in reverb. So it's about whether there's any sort of subtle bouncing off of objects or not. Canyons or craters. Ice chambers or caves. This one's a bit more pronounced in really might hear a bit of an echo if there was a chamber on some of the planets. And then a more sci-fi-ish, meaning it just pushes the extreme a bit more. Okay, a few more settings that I have. So seismic, meaning not wind and weather, but more about volcanoes and quakes or things like that happening. Mars has regular occurring quake-like sounds. Let's have a listen to that now. So it's a much more kind of consistent sound. It's ongoing and regular, but it's this idea that it would be the planet rumbling. The other consideration that I have in this widget is this idea of different planets would have different tunings. I don't mean every sound. I'm particularly referring to sound produced in an air column. I was thinking about like an orchestra. If you were to put an orchestra on different planets, would they sound different? If they were the same instruments playing the same music, would you hear a difference in tuning? And yes, you would, because the instruments with air columns like woodwinds, brass, etc., they would be affected on planets that have things like helium, like I have now, Jupiter, hydrogen and helium. So helium would affect the sound, not the entire sound though. On the woodwind instruments, yes. But if you think of something like a voice, and like when you have helium on Earth, when you suck in a balloon with helium, the pitch of your entire voice isn't changed. It's your fundamental frequency remains the same, but the formants of your voice become pitch shifted. And that's different on woodwinds and brass, where the entire sound would be pitch shifted. So in this example, I've allowed for as if you were playing a clarinet into this system and you want to hear what the clarinet would sound like on different planets. This button allows for that to happen. If there was an orchestra on these planets that I've just shown, the violins would stay the same pitch as intended here on Earth, but the woodwinds would have these different pitch shifts. So right now we're on Jupiter, and you can see beneath this button it says shift 19 semitones. So it's plus. So the sound on Jupiter with an air column instrument would be 19 semitones up. Whereas on Mars, the clarinet would be minus 6 semitones down. So it's interesting to think about. It's not, again, not for all sounds, but it's interesting to dip into that world of these sounds that would be altered by the gas composition because they are a part of air columns. They have air columns. Humans have air columns when we talk. So part of our voice would be altered, but not the fundamental frequency, which is a really interesting area. I think that's kind of about it, except for the fact that you can also record into this system as well. I've got a variety of samples to choose from. But you can also, if you use the Unreal Engine version of this platform, you can just hit record. And it should just play back. You have this idea that you could record something into the system and it would play it back through the planetary settings. So you could record your instrument live, you could play music through it and hear what the music sounds like and play around with it, explore different planets that I haven't even put here as a preset, and just explore it as like a little playground. So there's so many customizable settings. All these parameters are customizable, so you can get in there and do it individually if you like. The range is too small for you, you can increase the intensity to really exaggerate it. And really there's lots of potential here for this to be either a research tool, education tool for students to explore different settings and understand all these parameters in an accessible way, or be adapted into a bigger system. It could be used in museum settings, educate the public. There are so many different parameters for this project. I'm really excited to put it out there. So check out the website. My links to my website to give you information about how to download it. Like I said, you've got the Unreal Engine version on the Fab Store, but I've also got a standalone version just to test it out a bit. It doesn't have all the functionalities, like Record is the main one, but it can do everything else, and so you can quickly dial it up and give it a go. So yeah, feel free to check it out, and thank you very much.